Hello everyone, good morning. I hope all of you are good and I am also fine. So today I will take another class from mathematics and the topics is same topics from linear differential equation, and this is the last part of the linear differential equation. So here I will do 4 or 5 questions from different methods. Okay, so our first question is like that: solve the differential equation. This one, x dy plus y equal to cos x plus sin x, given y of pi by 2 equal to 1. That is the below when x equal to pi by 2, so below y is 1. So let's try x dy dx plus y x cos x plus sin x. Okay, now dy dx plus y by x equal to cos x plus sin x by x. Okay, cos x by sin x plus x. So here this is the differential equation. Here p is what? 1 by x. Q is what, sir? Cos x plus sin x by x. Okay, now we have to find integrating factor. This is e to the power p dx, so e to the power 1 by x dx, so e to the power log x, so x. Now we will do solution. The solution of the differential equation will be like that: y into if integration if into q dx plus c. Okay, y into x, if is what? X, and q is cos x plus sin x by x. Okay, dx plus c. So yx is equal to x cos x plus sin x dx plus c. Now integration x cos x dx integration sin x and dx plus c. Here I split the integration in two parts. Okay, the first one is x cos x and the second one is integration sin x. So now if I here it is u into b form, so x integration cos x dx dx of x cos x and dx plus integration sin x is minus cos x, sin x is minus cos x plus c. So it will be x sin x minus cos x plus c. Okay, so x sin x minus cos x plus c. So y into x it will be like that. Now we have to putting x is equal to pi by 2, y equal to 1. So y 1, this one is pi by 2, x equal to pi by 2, this is sin pi by 2, sin pi by 2 minus cos pi by 2 plus c. So pi by 2 equal to pi by 2 into 1 minus 1 to 0 plus c. So pi by 2 equal to pi by 2. This one will cancel. So c will be minus c. Sorry, c will be 1. Now from equation 1 we get what? We get x y x sin x minus sin x minus cos x plus 1. Okay, so let me explain in 10 seconds again. So this is the given equation. We have to find out the differential equation of to solve this linear equation. Okay, I first divide both sides by x. After that it is in the form of dy dx plus py equal to q. Now here p is 1 by x, q is cos x plus sin x plus x. So I find what is integrating factor. It came x, and the solution is y into if, I into q. I just put this value and multiplying by x, it becomes after that I split the integration x cos x and plus sin x. Okay, now this here is it is in the form of u into b. So I use u into b formula here. and after that equation, this one is equation 1, and we have to put the value of x equal to 1 when y x equal to pi by 2 when x equal y equal to 1 when x equal to pi by 2. Just put the value and simplify, find out the value of x is 1, and again I put the value of c in equation 1, and this is the final answer. This is the final answer of the solution. Okay, I hope all of you understand this one. So our next question, this question number 2 is like that. Find the particular solution of the differential equation. This one given y equal to 1 when x equal to y equal to 0 when x equal to 1. Okay, so let's try to solve it. The given equation is like that: x dy minus y, this is x plus 1 e to the power minus x. Now dy dx y by x is equal to x plus 1 by x e to the power minus x. Okay, so here this is the differential equation. Here p is minus 1 by x, q is x plus 1 by x e to the power minus x. Okay, now we have to find the integrating factor. Integrating factor is what, sir? E to the power p dx, right? Okay, fine, sir. Minus 1 by x dx, so e to the power minus 1 by x dx, e to the power minus log x, x minus 1, that is 1 by x. So solution is what? What is the solution of the equation? Y into if and if into q dx plus c. Okay, so y into if is minus 1 by x, sorry 1 by x, this 1 by x into x plus 1 by x e to the power minus x and dx plus c. So 1 by x is equal to, it will be 1 by x e to the power x dx and minus x dx, 1 by x square e to the power minus x and dx plus c. So up to this much clear, I think, for everyone. But here, look at here, I use the formula and this one came. After that I keep multiplying this one. This one, if I multiply this one, it will be x by 1 by x square e to the power minus x dx plus 1 by x square e to the power minus x dx, right? Okay, and here again we will do, this one is u, this one is b. We will do integration by parts here, and no need to do here. Okay, no need to do this term. I only do this one, right? So 1 by x e to the power minus x dx, integration ddx of 1 by x e to the power minus x dx plus c, and it will be 1 by x square e to the power minus x dx. So 1 by x, it will be e to the power minus x minus minus x. Okay, here it will be minus 1 by x square e to the power minus x by minus 1 dx, 1 by x square e to the power minus x dx plus c. So minus 1 by x e to the power minus x, here it will be minus 1 by x square e to the power minus x dx, 1 by x square e to the power minus x dx plus c. This one will cancel. So y by x minus 1 by x e to the power minus x plus c. This one is equation number 1. Right, now putting x equal to 1 when y equal to 0, or y equal to 0 when x equal to 1. So if I put this below here, it will be 0. Here it will be 1 by 1 e to the power minus 1 plus c. So it will be e equal to e to the power minus 1. So c equal to 1 by e. Now put the value of c in equation 1. So from equation 1 we get what will we get? Y by x minus 1 by x e to the power minus x plus 1 by e. So this is the perfect correct partial differential. This is the partial solution of the differential equation, given differential equation. Okay, so let me explain it again from the beginning. This one is given. I write in the form of dy dx plus py equal to q, and linear differential equation. P is what? This one, and q is this one. After that I find out what is if. It's simple. and use the solution formula. I try to find out what is the solution. So after that I am multiplying this one. Here it will be u into b. I take this second term as it is. After simplifying, what becomes, this will be cancelled, and this will be the, it will be the main solution of differential equation, linear differential equation. Now we have to find out the partial solution. Partial solution means you have given x and y, x is 1 and y is 0. By putting this value, you have to find out the value of c, that is constant is what. After that I put the constant in the same equation, and answer will came out this one. Okay, I hope. So student, our next question is, there is question number 3 is like that. Find the particular solution of the differential equation, this one, given that when x equal to 0, y equal to 0. Now you have to convert this differential equation in the linear form. It may be dy dx plus py equal to q, or it may be dx by dy plus px equal to q. Okay, so let's try. Minus x dy equal to 1 plus y square dx. So dy dx is equal to 1 plus y square by tan inverse y minus x. Okay, so now I convert it like the dx by dy tan inverse y minus x by 1 plus y square. Okay, so tan inverse y by 1 plus y square minus x by 1 plus y square dx by dy, dx by dy plus x by 1 plus y square equal to tan inverse by 1 plus y square. So here p is 1 by y square, q is tan inverse y by 1 plus y square. Okay, so what is the solution? The solution of the differential equation is like that. Solution is y into if into q divided, sorry, y, it will be x into if into q dy plus c. So the differential equation is in the form of what? It is in the form of dx by dy plus px equal to q, is not it? The differential equation is in the form of dx by dy plus px equal to q. So here p will be 1 by y, 1 plus y square, and q will be this one. Now before finding a solution, we have to find out the integrating factor is what, sir? Integrate e to the power p dy. So e to the power p dy, p is what? 1 by 1 plus y square dy. So it will be e to the power tan inverse y. Okay, so integrating factor is what? It is about tan inverse y. So the solution is like that. X into if equal to if into q dy plus c. Okay, right? So write the value of e to the power tan inverse y, e to the power tan inverse y into q. Q is what, sir? Tan inverse y plus y square dy plus c. Okay, so let tan inverse y equal to z, 1 by 1 plus y square dy equal to dz. So therefore x into e to the power tan inverse y equal to e to the power z dz plus c. Okay, so now here again it is in the form of u into b integration by parts, is not it? Again it is in the form of integration by parts, u into b. Fine. So what it will be e to the power z dz minus integration ddx of z e to the power z dz plus c. So x into e to the power tan inverse y z 1 e to the power z dz plus c minus e to the power z plus c. So it will become no z minus 1 plus c. Okay, so z is what? Tan inverse y, that is tan inverse y minus 1 plus c. So what is the answer? The solution of the differential equation is x into e to the power tan inverse y. Okay, x into e to the power tan inverse y is the solution of the. So let me explain in 10 seconds again. So what is the equation? The equation is given like that here, like that, and I find in the form of we got the differential equation in the second case. Okay, that is dx by dy plus p equal to q. Here p is this one, q is this one. After that I find the integration factor is what? P dy, e to the power p dy, it became e to the power tan inverse x. Again use the same formula. After that here I take tan inverse y is z. That means after simply putting the value what is in the, it is in the form of integration into b, right? Now I am simplifying this equation. After that I put the value of z. Now we have to put the value of x and y 0 here. So partial division, so it will be 0, it will be 0, it will be 0 minus 1 plus c. So 0 minus 1 plus c. Okay, that is e to the power 0 is what? 1. So it will be 1, c will be 1. So put the value of, so solution will be x into e to the power tan inverse y equal to e to the power tan inverse y minus 1 plus 1. Okay, so this will be the what? The partial differential equation of the question. Got my point? Okay, I hope all of you enjoy this. So our next question, that is it is the last question. Okay, the last question of the class, that is of the linear differential equation part 2. Okay, I already solved all the pattern of linear differential equation what maybe came in the 2 videos, 2 lectures. There is 8 questions is there. If you follow these 8 questions, you can do any one of the differential equation from any book, CBSE, ICC, state board, whatever it may be. Okay, so let's try to find out the particular solution of the different given differential equation. This one is given differential equation. Here y not equal to 0, y is pi by 2 and x equal to 0. So let's try to find out dy dx x cot y, y square cot y, right? So here p is x, sorry, p is cot y. It is in the form of dx dy px equal to q. Okay, so it will be p, it will be q. So q will be 2y plus y square cot y. Now we have to find out the integrating factor is what? E to the power p dy, e to the power p cot y dy. So what is the value of cot x? This is log sin x, that is sin y. E to the power integration will be log sin y. So it will, e log will be cancelled out, so sin y will be the integrating factor. Now solution. So y into if into q dy plus 6. So if is sin y, q is 2y y square cot y dy plus c. If you multiply it, this one, this will be 2y sin y dy, and it will be y square cot y dy into sin y dy. Okay, the solution is like that. I put the value of if here, so it will be x into, sorry, it will be x into if into q. If is sin y, cot is 2y plus y square cot y. So I multiply this sin y 2y dy plus integration y square cot y sin y dy. Okay, fine. Now therefore x into sin y is equal to 2y sin y dy. It is equal to integration y square cos y by sin y into sin y dy equal to sin y plus y square cos y dy. Okay, now this is also in the form of u into v, this is also in the form of integration u into v. So we will do it here. We will do the integration simplify by using by parts. Because of y, if I derivative y square, it will be 2y, and after the one term will be cancelled out. If there is like the two terms is came, then always you try to do one term and other term will be automatically cancelled out. after doing the by parts u into v, and which term we will store, sir? This is the question, which term we will store to do the integrations. So you always try to this one, look at the u, and after that differentiate u is what come. If it is similar to the previous one or last one, so this term you have to do. No, since here it is y square, the derivative y square is what? 2y. Now here is 2y, so then cos y integration is sin y. So this part and this part, after using the formula, one part of this integration and this part will be cancelled out. Okay, so we have to find out in this way. Sin y dy y square cos y dy minus dy of y square cos y dy x sin y 2y sin y dy y square sin y minus it is 2y sin y dy plus c. This will be sorry, this is y square sin y, this will be cancel out. Okay, this term this will be cancel out. Similarly, this type of in this type of cases, one after you are drawing one u into b, one term will be cancelled out automatically. No need to do the both term in by parts. Okay, so what become, it will be sin y. Okay, now equation 1. Now I putting the value of x is what? 0, y is pi by 2. So it will be 0 and it will be y is pi by 2. So pi by 2 square by 4 into sin, it will plus c. Sorry, it will be plus c sin pi by 2. Okay, plus c. It will be 1. So it will be c will be minus pi square by 4. So now what will be the answer? X sin y square sin y minus pi square by 4. So this will be the actual partial differential solution of the differential equation. Okay, so let me explain in 10 seconds. First I write this one, p is here, u is here. If I find out, then use the formula of solution, I write it, and after that I multiplying it, and after that there are 2 times this came, which time we will do? This time we will do where the u, after doing the u, there is differentiation of the u which is matching the other term. So this is, if I do if differentiate here, it matches this term. So this term will be differentiated by using the integral by parts. So after using this integration term and this term will be cancelled out. This will be the solution of the differential equation, and we have to find out the value of find out the partial solution. So we have to put the value of x and y here in this equation. After that we find c is minus 5 square by 4. So I put the value of c in this equation. Okay, and this is the final partial differential equation, that is x into sin y equal to y square sin y minus 5 square by 4. So I hope all of you understood and enjoying this my class, and the linear differential equation is completed. Okay, in 2 lectures, 8 questions are there, and if you do 8 questions properly and you understand properly, so completely, then you can do any one questions from any books or any from any board. Okay, so we will do next class will be application of integrals. Okay, so remind it, next class will be our application of integral, right? We will do in 2 classes. So thank you for watching. I hope